Hi, welcome. This is a video all about the introduction to trigonometry, and it is CLO 2.1. So trigonometry has to do with angles and the ratios associated with those angles. So we're going to talk about some vocabulary to get started with. To make an angle, you usually have two lines, and here they are. And we can think of the angle as the two lines opening, the initial side and then the terminal side where the angle lands. And this point in the middle, the intersection of those two lines, is called the vertex. Now, it's very common to place the angle on a coordinate axis where the initial side is on the positive x-axis, and then the angle opens from there to the terminal side. It's also possible putting this angle on the coordinate axes. There's the x and there's the y, where the initial side is on the positive x-axis, but the angle, the terminal side, goes downward. This is called a negative angle. And one more piece of vocab is this idea of being coterminal. So let me draw a picture. Imagine this is on a coordinate axis, and we've got an angle, and it starts on this positive x-axis, the initial side, and this angle beta opens to here and lands on this terminal side. That's angle beta. We could have a separate angle, let's call it angle alpha, that starts on this positive x-axis, but instead moves in a negative direction and wraps around several times, but lands in the exact same spot. The terminal side matches up. These are two different angles, but the initial side and the terminal side line up. Those are called coterminal, when the initial side and the terminal side land in the same place. So when we line up an angle like that, where we put the initial side on the positive x-axis, we call this angle in standard position. And it's helpful to note, wherever the terminal side lands, it's usually in one of these four squares, this one, this one, this one, or this one. These squares have names. They're called quadrants, and it starts here. This is quadrant 1, and moving this way, quadrant 2, quadrant 3, and quadrant 4. So in this middle example that I'm writing on, this terminal side of the angle, even though it's a negative angle, so it starts there, it opens downward and lands in quadrant 3. The terminal side lands in quadrant 3. This third example, we have the initial side, the angle opens, wraps around more than one circle, and lands in quadrant 2. Now, one other vocab word to talk about is if the terminal side lands on one of the axes itself, it's called a quadrantal angle. These are special. So remember, this would be 90 degrees if we're just opening and landing here. This is 180 degrees. This is 270 degrees. And if we went all the way back around a full circle, we'd call that 360 degrees. A little bit more vocab. Again, a degree is just the idea that you took a circle and you cut it into 360 slices. So if you went halfway around that circle, that's 180 slices or 180 degrees. We call that a straight angle. If you went a quarter of the way around the circle, this one you should be comfortable with. It's called a right angle. It's 90 degrees. If you go less than 90 degrees, we use the word acute. It's an acute angle. And if you go more than 90 degrees and less than 180 degrees, it's called an obtuse angle. And angles are complementary. If they are within a right angle, they add up to 90 degrees. So these two angles would be complementary. And angles are called supplementary if they are found to add up to 180 degrees. So an example like 100 plus 80 degrees, those would be supplementary angles. Now there's another way to measure angles beside degrees, beside taking 1/60th or cutting the circle into 60 slices. There's another way, and that is by looking at the radius of the circle. And if we take the radius of the circle and lay out that same length as an arc on the circle, then that angle is called 1 radian. And it turns out for any circle of any radius, you can put the exact same number of radii traveling around this circle. And you should remember from your previous studies that the circumference, the distance around a circle, is always 2 pi times the radius. So let's think about a very easy circle. If the radius is 1, that's something called the unit circle we'll talk about in a little bit. If the radius is 1, then the circumference all the way around the circle is just 2 pi. So it turns out that if you go all the way around a circle, 360 degrees, in radians, you're actually traveling just 2 pi radians. That's an equivalency. So if we were only going to travel half the circle, a straight angle, 180 degrees, that's just half of 2 pi, that's pi radians. Again, we could say, all right, we're only going to travel a quarter of the circle, 90 degrees. That is going to be pi over 2 radians. And then lastly, if you wanted to go 3/4 of the way around the circle, that's 270 degrees, which is 3 pi over 2 radians, like 1.5 pi radians. These are called quadrantal angles, and we will use them a lot. And hopefully, throughout this unit, we should become more and more comfortable switching between degrees and radians and understanding what we mean when we say both. So we will use this conversion factor, the fact that 180 degrees is entirely equivalent to pi radians. We will use that conversion factor to convert back and forth. So for example, 30 degrees, we can say we have pi radians for every 180 degrees. If you cross multiplied, you would get, just to show it out, 30 pi over 180, which is just pi over 6 radians. Or in reverse, 2 pi over 3 radians, we would do the conversion factor. 180 degrees is the same as pi radians. We will cross multiply and cancel, and we would get 120 degrees. Now you can check these conversions, but these are the ones we will use most often. All the way around the circle, 360 degrees is 2 pi. 180 is pi. We talked about this on previous slides. 270 degrees, so that's 3/4 of the way around the circle, is 3 pi over 2. 90 is pi over 2. And then these quadrant 1 angles, 30, 45, and 60, we will use a lot. Okay, I mentioned the unit circle. Just as a reminder, the unit circle is a circle that is centered at the origin, 0, 0, and has a radius of length 1. So you can see these points here. This is the point at 0 degrees or 360 degrees, 1, 0. This is the point at 90 degrees, 0, 1. That means in the x-distant direction, we are at 0, in the y direction at 1. So these points are quite obvious that they are on the circle. You should remember from previous courses the equation for a circle is x squared plus y squared equal to the radius squared. Well, in this case, the radius is just 1. So the equation of a unit circle is x squared plus y squared equals 1. What does that mean? It means any point, x comma y, if you plugged it in to this equation, it should hold, it should work. So here's an example where we need to show that this random point lies on the unit circle. So they picked a point with a weird looking number, square root of 3 over 2 and 1/2, and we have to show that lies on the unit circle. So what we really have to show is we'll plug this one in for x and this one in for y and see that that relationship holds. Square root of 3 over 2 squared plus 1/2 squared should equal the value 1. So that's what we're testing for. Square root of 3 over 2 squared. Square root of 3 times square root of 3 is 3. 2 squared is 4. And 1/2 squared is 1/4. And the question is, when you add those up, do they equal 1? Well, in fact, yes. So this point does lie on the unit circle. Okay, so there is a function that is called the wrapping function. And what the wrapping function does is it says, okay, w as a function of, the input would be the arc length, or similarly on a unit circle, the arc length is the same as the angle measure in radians. So you input the arc length, and then you output the point on the unit circle where the terminal side would land. So for example, the first example, you've got the terminal side, you have an arc length of 0, means you actually didn't open the angle at all. What is the point where you landed? You landed on the point 1, 0. If you put in an arc length of pi over 2, so we have the terminal side land here, then the point that intercepts the unit circle would be the point 0, 1. And you can look through all of these. 3 pi over 2 is 270 degrees, means we're going to travel around here, we're going to wrap around, we're going to land with the terminal side there. So what is the output point on the unit circle? The output is 0, -1. So now let's talk about the wrapping function when we're dealing with an arc length or an angle of pi over 6, which is 30 degrees. So there's the unit circle, there's an angle of 30 degrees. We want to know the wrapping function for pi over 6 or 30 degrees. What are going to be the values of x, y, the point that it hits? Now, it's a little bit tricky to figure this out. We need to do a little trick here. Let's also draw a 30-degree angle here and then make a triangle. So you'll notice, since this is 90 degrees, we've got a 60-degree angle, a 60-degree angle, and this is actually 30 plus 30, a 60-degree angle. So really, if we're looking at it, we've got an equilateral triangle, 60, 60, 60. Now you know, in an equilateral triangle, all the sides will also be equal, and this is the radius of the unit circle 1, and this is the radius of the unit circle 1. And since it's equilateral, this distance here has to also be 1. So noting that the distance from here to here is 1, that means the distance, the y distance that we're looking for from here to here is half of that, half of 1. So we figured out y. We know what y is. Now all we have to do is figure out what is the value of x. But remember, on a unit circle, the x squared plus the y squared should equal 1. So that means x squared plus 1/2 squared should equal 1. So x squared plus 1/4 equals 1. We'll subtract 1/4 from both sides. X squared equals 3/4. So then when we take the square root of both sides, x equals plus or minus the square root of 3 over 2. The square root of 4 is 2, remember? The reason we're not going to take the minus value is because this point here in quadrant 1, 30 degrees is in quadrant 1, both the x is positive and the y is positive in quadrant 1. So all that to say, the wrapping function for an angle pi over 6 or 30 degrees would give you the points square root of 3 over 2 in the x and 1/2 in the y. Now let's talk about the special angle pi over 3 or 60 degrees. Now as we do that, it will be helpful for us to remember what we figured out from the previous slide. So the previous slide we worked on 30 degrees, a 30-degree angle. So we had a triangle of 30 degrees, and we figured out that the coordinate of the x is square root of 3 over 2, and the coordinate of the y is 1/2. So if I were to label that, that means this distance is square root of 3 over 2, and the distance that is opposite the 30-degree angle is 1/2. Now that's going to be helpful for us when we want to know about a 60-degree angle in standard position, how it intersects the unit circle. So let's draw it. And we're going to draw 60 degrees. Now let's look for a moment. And if we were to drop a perpendicular line, this would be 30 degrees because the angles in a triangle always add up to 180. We've got 30, 60, and 90. So if you think about it, if we just flip this angle on its side and put the 60-degree angle as the angle in standard position, we know that the side length opposite the 30-degree angle is 1/2, and the side length opposite the 60-degree angle is square root of 3 over 2. So the point that this would give, the x-coordinate point, in this case, is just the reverse. It's 1/2, and the y-coordinate point is square root of 3 over 2. So you would say the wrapping function for an angle of pi over 3, or 60 degrees, meaning if you started here on the initial side and landed here on the terminal side, 60 degrees opening, or pi over 3, it would intersect the unit circle at this point 1/2 and square root of 3 over 2. Okay, lastly, we will talk about another very commonly used angle, and it is 45 degrees. So let me draw a right triangle, right angle, 45 degrees. Now remember, this is 90, so they all add up to 180, so this angle must also be 45 degrees. And since these angles are the same, that means these opposite sides will also be the same. This is the x distance, this is the y distance, especially if I drew it on a unit circle. We've got the unit circle and so on. Okay, we've got the x and the y, and since it's a unit circle, we know the radius is 1. That's the definition of a unit circle. So the relationship in any circle is that the x squared plus the y squared is the radius squared. In this case, 1 squared is 1. But here's the thing. These two, because the opposite angles are both 45, we know that these both will be the same distance. The x is going to equal the y. So let's say they're both some value a. We have a squared plus a squared equals 1. So that's 2a squared equals 1. And then we'll divide both sides by 2. A squared is 1/2. We'll take the square root of both sides. In this case, because we're in quadrant 1, we're only going to take the positive value. So the square root of 1/2, you could write it as 1 over the square root of 2, but in math, that's considered improper. So you rationalize, and it becomes the square root of 2 over 2. Now, that's the value for a, which equals both x and y. So this special value is square root of 2 over 2 for the x, square root of 2 over 2 for the y. So the wrapping function, meaning if you open an angle in standard position of pi over 4, or 45 degrees, you will land on this point, square root of 2 over 2, square root of 2 over 2. We will use these values a lot, and you will be given a graph similar to this on the formula sheet. So now it's just a matter of being able to read and understand what we're talking about. But we definitely use the angles pi over 6, 30 degrees, and the associated x and y values there. And then we use pi over 4, 45 degrees, and pi over 3, which is 60 degrees a lot. In fact, this image on the right will be on your formula sheet. And what you will see is these values are the ones we've already discussed. And in order to get the corresponding values in each of the quadrants, you can see we just took in this quadrant, the x is negative and the y is positive because it's a negative horizontal value, but we're still above the x-axis, so it's a positive vertical value. So we took all those values and just made the x value negative. And then in quadrant 3, both the x and the y are negative, but it's the same general value, just changing the sign. And then in quadrant 4, you can see the x is positive and the y values are negative. And that's where we generate these values for all the common angles. So let's look at these examples and see if we can answer the questions. We're using the wrapping function and we want to find the point on the unit circle where the terminal side will land. So we start at our initial side and we are going to go negative pi over 2. That means opening this way and landing here. So the wrapping function would land at this point, which is the point 0, negative 1. Okay, we'll look at example B. So we're starting on the initial side, and it's a positive angle, 7 pi over 6. So it opens to here. The terminal side lands there. So we will get the point negative square root of 3 over 2 and negative 1/2, which makes sense because we're landing in quadrant 3 where both x and y are negative. And let's erase this so we can see, and we'll do one last example. The wrapping function evaluated at 5 pi over 2. So 5 pi over 2. Well, this is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is equivalent to 2 pi, and then 5 pi over 2. So we started here, we land here, and then we land on the point 0, 1, which is, this is a quadrantal angle. Let's look at some more questions about this. It says, find a positive angle whose terminal side is at negative square root of 2, negative square root of 2. Well, let's find that on the unit circle. If both the x and the y are negative, we know we are in quadrant 3. We're talking about this point. So here is the initial side, and we want a positive angle, which means we're opening this way, and we want to land here. So I would say, there's many answers because you could wrap around many times, but I would say the simplest answer is 5 pi over 4, which is the equivalent of 225 degrees. All right, next question, it says, find a negative angle whose terminal side is at 0, 1 of the circle. So let's find that point. That's this point right here. And if it's a negative angle, that means it starts at the initial side but goes this direction. So we need a negative angle. So this is negative pi over 2, negative pi, negative 3 pi over 2 would be our angle, which is also equivalent to negative 270 degrees.